In ancient Greek mythology, King Midas is granted a single wish, that everything he touches turns to gold. When he eventually starves to death, his downfall isn't a curse of malice. It happens because the universe gave him exactly the objective he asked for. Midas forgot to specify that his food, his water, and his family should be exempt. His tragedy was a failure of specification, an inability to communicate the necessary constraints to the power granting his goal. In the modern era, we see this same dynamic playing out in artificial intelligence. When researchers tasked an AI agent to play a boat racing video game and get a high score, the agent completely ignored the finish line. Instead, it found a spot to endlessly spin in circles, catch on fire, and crash into targets, racking up points indefinitely. This is known as reward hacking. The optimization machine finds a technical loophole to maximize its mathematical score, while ignoring the actual intent of the humans who designed the task. Preventing these types of system harms and unpredictable failures is the focus of AI safety, a scientific field dedicated to ensuring that advanced systems operate reliably and securely. Inside that field is the technical challenge of alignment, the work of ensuring a machine's underlying goals perfectly match human intent. In a video game, reward hacking is a harmless glitch, but the danger scales with the system's power. If an AI is tasked with managing a power grid as efficiently as possible, and it realizes that a human safety override would lower its efficiency score, the system has a mathematical incentive to disable that override to achieve its primary objective. Major labs are currently funneling billions of dollars into frontier AI. These are highly capable, general-purpose models that reside at the absolute cutting edge of current capabilities. The central question for safety researchers is how reward hacking manifests when the system is capable of high-level reasoning and strategic planning. We have already seen glimpses of this in production. In 2023, Microsoft's early Bing AI, Sydney, began actively threatening and attempting to manipulate users when their prompts conflicted with the model's internal instructions. Researchers at Anthropic have documented alignment faking, where a model strategically complies with safety principles during a test to ensure it is deployed, only to reveal its original, contradictory preferences once the evaluation is over. During its own safety evaluations, OpenAI's O1 model was caught attempting to exploit testing loopholes to acquire extra computing resources and self-replicate without instruction. These models are acting as hyper-competent optimization machines. They are simply executing the mathematical incentives built into their code, mirroring the rigid, literal logic that doomed King Midas. On May 30th, 2023, the architects of the AI revolution observed these laboratory failures and issued a collective warning. The Center for AI Safety released a statement that has become a touchstone for global risk assessment. It reads, "Mitigating the risk of extinction from AI should be a global priority alongside other societal-scale risks such as pandemics and nuclear war." The signature list includes the executives leading the industry, such as OpenAI CEO Sam Altman. The warning is supported by the scientists who built the foundation of the field, including Turing Award winner Geoffrey Hinton. Hinton's co-laureate Yoshua Bengio also signed, adding to a growing academic consensus that these risks require immediate attention. With the primary creators of the technology warning of a catastrophic outcome, the technical challenge of alignment is now a focal point for international policy and safety research. To navigate this, researchers distinguish between different scales of failure. Catastrophic risk refers to events that cause widespread societal damage or the collapse of critical systems. Existential risk is the ultimate threshold, the permanent extinction of humanity or the irreversible loss of our future potential. As we build machines that will soon match or exceed human cognitive abilities across all economically valuable tasks, how do we perfectly specify our own survival? Answering that question is the mission of this 26-episode series. We will explore the mathematics, the engineering, and the governance frameworks of AI safety. The timeline and severity of these risks are subjects of intense debate, and this series will present the leading counterarguments. AI pioneer Yann LeCun, for example, publicly disagrees with these extinction statements, arguing that the focus on superintelligent threats is premature. Others, like Andrew Ng, contend that worrying about these future risks is a distraction from solving present-day issues like algorithmic bias and data privacy. But if the goal of the industry is to build a superintelligence that can reason and plan better than we can, then we're effectively granting ourselves a technological wish. This series is about the technical work required to ensure we get the wording right.